What are we gonna do today? We're gonna do part A3C of the Chromatography Lab.
In this experiment, we will use thin layer chromatography, or TLC, to separate a mixture of three components: fluorine, fluorinol, and fluorinone. We have fluorine, fluorinol, fluorinone, an unknown, and a mixture of fluorine, fluorinol, and fluorinone, which is our reference. We're going to figure out what is in unknown 1. Now we take a 10 by 5.3 centimeter TLC plate out of our dry box right here. And once we have the TLC plate, we want to make all our spots not on the back, that's the plastic part of the TLC, but on the front of where the silica part is. And now we take the TLC plate back to the hood. Back at the hood, we're drawing lightly a reference line, not breaking the silica, about a centimeter from the bottom. We're labeling the plate F1 for fluorine, F2 for fluorinol, F3 for fluorinone, U for unknown, and R for the reference. You can see them labeled here. Now we're going to spot. We're going to take a TLC spotter, what I have in my hand, and we just lightly spot each spot. The first one is fluorine, F1. We're at F2 is fluorinol, and F3 is fluorinone, the unknown mixture, and now finally the reference mixture. Once all the spots are on, we then need to place that in our TLC chamber, which is the beaker. We're going to fill the beaker with methylene chloride that we get from the hood. We're pouring the methylene chloride just enough to fill the bottom, doesn't have to be a lot. Now we're going to measure to make sure that the solvent is below the reference line. It must be below the reference line. We put the TLC plate in the developing chamber. As you can see, it's below the line. Cover it with tin foil and let it sit, not to touch it. When the solvent moves about 3/4 of the way up, we can take it out. Starting part B of the experiment, we take out benzyl, benzoin, and a mixture. We're going to test different solvents, and what we're going to do is take out 3 10 by 3.3 centimeter TLC plates. We're going to test 3 different solvents. We take out the 3 plates, take them back to the hood. Again, draw our reference line about a centimeter from the bottom, not breaking the silica gel. Very lightly draw our line. Then we're going to label it B1 for benzyl, and we label each of the 3 plates, then B2 for benzoin, and M for mixture. Again, B1, B2, and M, B1, B2, and M. Now we're going to spot the mixtures. We're going to take our little spotter, as you can see here. We stick it into our first benzyl for first vial. Through capillary action, the spotter pulls out the solvent, the compound mixed in the solvent, and we spot it just as we did in part A. And then we're going to spot B2, which is the benzoin, and then we are finally going to spot the mixture. Now we come to the hood and pour in dichloromethane to one of our developing chambers. That's one of the solvents we're going to test. Then we're going to pour hexane into another developing chamber. That's another solvent we're going to test. And then once the hexane is poured, we're going to take it back to the hood and label them. Dichloromethane, hexane is the second beaker. And finally, we're going to test acetone. We have that in the hood. We labeled the beaker here, and we just squirt a little acetone into the bottom. All our TLC plates are spotted, so we take the first one and we place it into acetone chamber. We cover it with tin foil here. Then we go to the second one, we place it in hexane, and we cover that with tin foil. And we now go to the third one, making sure the solvent's below the reference line, and we cover that with the tin foil. We just let them sit to develop. Now we go check our part A. We have to let that develop a little bit longer, and while we're letting it develop, we can start on part C. Here we're going to monitor a reaction by TLC. We're going to reduce fluorinone to fluorinol. In order to do that, we're going to set up 2 TLC plates, which we're going to get from our TLC box again, where we take 2 silica gel plates, 110 by 5.3 and one 10 by 4.3 centimeters. Again, we only mark the silica portion and not the back is the plastic portion. Back here, we're going to draw our reference line again, a centimeter from the bottom. And what we're going to spot this time is we're going to time it first time 0 seconds, second time we're going to take a spot from the reaction mixture. We'll be at 15 seconds, 30 seconds, 60 seconds, 120 seconds. We're also going to starting material and product, starting material and product. We can initially spot here, as you can see, our starting material, and we know our product, so we're going to spot that as well. They're basically the references. Now, we're taking a look at Part A. We're pulling out the TLC plates of Part A and Part B. We kind of have to multitask here. The first plate of Part A, we're labeling A for acetone. The second plate, we're labeling H for hexane. And the third plate, we're going to label M for methylene chloride. We're going to let those plates sit and dry. Now we're going to set up monitoring the reaction by TLC. We just put a stir bar into our reaction flask, and now we're going to have to go and weigh out fluorinone, which is our starting material, as you can see here. And then we're also going to have to weigh out sodium borohydride, the white powder, which is the reducing agent, and that'll take the fluorinone to the fluorinol. We put our fluorinone in our reaction flask, as you can see here, and the next piece we'll do is we will add 4 milliliters of methanol, and that's just a solvent to dissolve the fluorinone. All right, and now as the fluorinone's dissolving, we have to plug in our hot plate and our stirrer. You can see the stirrer. We're going to turn the stirrer on, put the reaction vessel onto the hot plate where it begins to be stirred. You can see it's stirring. The fluorinone has mixed with the methanol, and now we can spot it, and that's our time 0. And then we put it back on our hot plate to stir, and we add our sodium borohydride as our reducing agent, and once that's added, we start timing our reaction. And after 15 seconds, we will spot the first spot. As you can see, we're doing that there. And then after 30 seconds, and then after 60 seconds, and then after 120 seconds, our last spot, and notice the color change in our reaction mixture. Now we develop the 2 plates. We put them in our methylene chloride chambers. We cover it with tin foil and let it develop. Once developed, take the TLC plate out, draw a line where the solvent rose to. Once it's dry, we can visualize it under UV light. Okay, now we can visualize Part A of our experiment. We're going to do all our TLC plates. And in Part A, you can see under the UV box, we have our fluorine, fluorinone, and our fluorinol. And we're circling, each spot corresponds to a compound. We're circling them, as you can see, F1, F2, and F3. And the unknown, as you can see, contains F2 and F3. And the reference there contains all 3. So once we're done circling the spots, we can certainly calculate, or we will need to calculate our F values. And then for Part B, we can visualize the spots. Remember, we were determining whether benzyl and benzoin separated with acetone, hexane. Acetone, you can see all the spots ran to the top, no separation. Hexane, they all stood at the starting point, no separation. And in methylene chloride, you can see the mixtures were definitely separated. And you're going to let us know why methylene chloride was the best solvent. In Part C, we monitor reaction by TLC. You can see at 0 seconds it was starting material. At 15 and 30 seconds, you could see formation of product. And then at 60 seconds, there's less starting material. And at 120 seconds, there's only product. So now we can review the TLC plates. You can see at the top there's starting material at 0 seconds, and by 120 seconds there's only product left. Now for all our TLC plates, we will have to calculate for each spot an RF value, which is the distance traveled by the substance divided by the distance traveled by the solvent. Because under a set of established conditions, a given compound always travels a fixed distance relative to the distance of the solvent front. And this ratio is called the RF value.